All right, we're recording now. Here we go. So we're going to start with the empirical rule today, which is all about like how many standard deviations are on a bell curve. So the empirical rule, if I get it exactly right, make sure you have the correct definition. This is basically, it's just like percentages within certain standard deviations for a bell curve.
Ms. Nussbaum, are you supposed to see what you're doing?
Yeah, it says I'm sharing. It's not?
It shows like Schoology.
Oh, that's fun. Let's try again. It's okay. I only messed it up like 85 times a day. I'd be good at it now. No, still not. So are we good now, Krista?
Yeah, it's good.
Okay. So now this bell curve, you notice that this is like, here's the mean. And this is the mean plus like 1 standard deviation. And this one is the mean minus 1 standard deviation, and so on either side. So this is +2, this is +3, this is -2, -3. And it just tells you where everything is. So for example 1 says, in a survey, the sample mean height of women in the United States was 64.2 inches. And by the way, this a bell distribution is also called a normal distribution. Horrible bell curve. Ugh, twice bad. All right, so draw a bell curve. We're gonna do example number 1 together. Yep. One of my favorite things to do is to draw a bell curve, and like I always do it badly. And then there's always like some kid, normally in stats classes, not you guys, because apparently you're angels and really nice. But there's always that one kid who's like, good job, you know, like, and then I'm like, no, you do it now. You draw one. And then they're like, oh, I suck too. It's like, yeah, everybody. It's easy that first half. You're like, I'm killing it. And then you're like, nope, no. Okay, so here we go. This is right in the middle. It says that the mean height is 64.2 inches for ladies with a sample standard deviation of 2.9 inches. And we're supposed to figure out what percent of women are between this and this. So we're going to go figure out 1 standard deviation first, and then 2. Let's see if we need beyond that. So first I'm going to take 64.2 and I'm going to subtract 2.9 from both sides. This one gets me 61.3 here, and if I subtract another 2.9, I get 58.4. And then if I add on the other side, I get 67.1, and then add another 2.9, and I get 70. So there's ladies' heights normally. But we're looking for the percent that is between here and here. All right, so I'm going to give a prize to somebody who can tell me what percent that is between there and there. You're going to have to look at the bell shape next to it. Remember, if you don't have a printer at home and you're wishing that you had a printout of these notes, you can always grab them from me when you come into school next. I'll make copies. Caitlin, is your hand supposed to still be up? No. Anybody want to be in on this? Or am I just going to give another prize to Megan? Because I'm going to give it to her. Oh, like how Caitlin took her hand down, then put it up. Ah, that's funny. All right. Megan, you want to be 1 or 2?
2.
Okay. Caitlin's 1. Caitlin.
47.5%.
47.5%. That's exactly right. Because if you look over here, that would be 34% and 13.5% added together. So that is 47.5%.
I was about to say 1, but then I thought about Jerry, who said it's always 2.
Well, don't trust Jerry. All right, Caitlin, seal, sea turtle, crab, lobster.
Turtle.
Good call. All right, now Chevy Chevs is the one that you guys don't know, so we're gonna go over that now. Chevy Chevs basically says that the portion of any data set lying within K standard deviations, that's an important part, K standard deviation. So if I said 1 standard deviation or 2 standard deviations, but it has to be greater than 1 of any data set. What this means is that it doesn't have to be normal. And remember, by normal, what I mean is it doesn't have to be a bell curve. So the formula is 1 minus 1 over K squared. And I'm going to copy that down on the next page because we're going to use it for the next problem. The formula is 1 minus K squared. What was it? 1 minus K squared over, no, 1 minus 1 over K squared. Okay. So the age distribution of Alaska, the mean is 35.3 and the standard deviation is 21.1. Are you guys getting used to at this point? Every time you see a mu, you think in your head mean. And every time you see a sigma, you think standard deviation.
No, but.
Okay. So we're going to have to get better about that. Okay, so this is the mean, this is the standard deviation. We have to make a statement about the data using Chebyshev's theorem and K equals 1. Oh, I don't want K equals 1. I don't know why I put that. K equals, let's do K equals 2. Okay, now K means how many standard deviations away we are, right? So I'm just going to start plugging this in up here. I'm going to write 1 minus 1 over 2 squared. Which is 1 minus 1/4, which is 3/4. So I would say 75% of Alaska's population is between, and then I'm going to say 2 ages. And remember, it's 2 standard deviations. So what I'm going to do is I'm going to go to have 35.3, and then I'm going to add 21.1 twice, and then subtract 21.1 twice. So it's almost like, instead of like, imagine that on the other page, you know how the empirical rule made a lot of sense to you guys? I want you to think about that, but imagine that there's not a bell curve on top of it, almost just like a number line. So we can kind of think, okay, if I add 21.1 one time, I get 56.4. And if I add it again, I get 77.5. And then if I subtract it, oops, 35.3 minus 21 point, was it 1? I get 14.2. And then this one, I'd actually get a negative number, but I'm going to call that 0 because we're talking about ages of people, right? So the actual answer is at least At least 75% of Alaska's population is between 0 and 77.5 years old. And this is like a guarantee. Now, it's pretty obvious that I really bet that 75%, at least 75% of Alaska's population is between 0 and 77.5. I mean, that's not that crazy of a statement. But when you get other populations that are not normal, it can actually be quite helpful. So here's how I got my information. The 3/4 was right here, is that 75? That was from that formula, right? And then because we said that K was 2, because I said K was 2, that's how many standard deviations away you are. That's why I went 2 above and 2 below the thing. All right, so next up, what we're going to do is we're going to do a box and whisker plot. I wrote down the steps here. Find the 5-number summary of the data. That would be the minimum. The minimum, you need Q1, you need the median, you need Q3, and you need the maximum. So since I don't really have any numbers for example 3, how about we just use the data set that we just did in our calculators, remember? So go ahead again to stat, oh, and David, what we did was, which one did we use for that, guys? Was that 14?
Yeah.
So we did 14 from the last assignment, just using our calculator, David, and put those in there. Here, I'll show you. So these are just the numbers from number 14 on the assignment from yesterday, because we were talking about how to do it in our calculator. There's 10 of them. And then if you go to stats, calc, and hit one variable stats and enter, then we've got all of our data again. Everybody make sure that your numbers match mine. If you scroll down, you should have 160, 173, 182 and a half, 195, and 230. Do you have the same numbers, Megan? How about you, Michaela?
Yep.
Krista Tanner, you good? Okay, Caitlin Mitchell? Cool. All right, so now I'm going to draw a box and whisker plot. First thing you need is a number line. And we need to make sure that all of them are on there. Let's see, so we'll start at like 160, 170, 180, 190, 200, 210, 220, 230. And then some people just draw it above the number line, but I think it's easiest just to draw dotted lines and then fix the dotted line. So here's my minimum, which is 160, and here's my maximum, which is 230. Let's see, Q1 is 173. On the top here, I'm going to write what these numbers actually are, just in case somebody wanted to know exactly. The median was 182.5. You don't need to draw those numbers on top if it was something obvious like 160. See how I went right through it? But like 182.5, there's no way that you could just look at my drawing and guess that I was drawing exactly 182.5. Q3 is 195. And to do this, by the way, what you would actually do if you were doing this by hand is you would write them all out in front of you, split it in half, and there would be your median. And then you split the bottom half in half. And the median of the bottom half is Q1. The median of the top half is Q3. This was what, 195? And then you draw a box between Q1 and Q3 with a line at the median, and then whiskers that go out there. This will show you the bottom 25%. This is the middle 50%. This is the top 25%. Okay. Now, here's a question that is important. Let's see if you guys can get it and who can get it. Are there the same amount of, what was this? I don't remember what this problem was about. Anybody remember what this data was about? No? It was
Weights of presidents.
weights of presidents. All right, so these are the weights of presidents. Are there the same amount of presidents in this area as in this area?
No. Oh, wait, yeah, because they're both 25%.
Yep,
They just cover different ranges.
exactly. Good, Megan. So what Megan just said is, first she said, no, because one looks way bigger than the other, right? But they're both 25%. It's just that more dudes are crammed into here than in this area, okay? There's still, I don't know how many it's going to be, like, how many? Biden is our what president? Anybody know?
47.
All right, well, let's say he's number 47. So there's about like 12 in each of these, okay? Right? So there's 12 dudes down here and there's 12 dudes up here, but like, I don't know, who is our fat, wasn't there like a Teddy
Really big guy.
Roosevelt or something?
No, it was like a really guy, he got like stuck in his bathroom.
Taft? It doesn't seem like 230 is that big, does it, for a dude?
I feel like he was like 400 pounds.
Yeah, I don't know if I agree with this, but okay. Anyway, so, but what we're saying is that there's still like 12 guys up here. It's just they're more spread out. So it looks like more, but it's not. It just shows you how spread out the data is. All right. A z-score is how many standard deviations a value x lies from the mean. So that's x minus mu over sigma. Oh, it's not all the presidents. Remember, it was just from 1952. We were just looking at 10 presidents. So that doesn't make sense that I said 12 would be in each category. But if this was everybody. X minus mu over sigma is z-score. All right. Let's give a prize for this last one. See who can do it. It says that the average grade on a stats test is a 63% with a standard deviation of 12% and normally distributed. The normal part is important because otherwise you can't do a z-score at all for it. You score a 72%. How does your grade compare to the rest of the class? Let's see who remembers how to do this. I'll give you guys all a little bit of time. Okay, so I got the right one today, and what you're saying is that what I labeled yesterday is the wrong one. Got it, okay. So that should have been page 62. I wonder if Tanner and David submitted the right thing. Tanner, did you submit page 62 there or page 74 there in yesterday's stuff?
62.
Nice.
think.
I like how everybody's just like, she means something else. And you're right, I did. Page 62. There's no reason to resubmit if you already submitted page 62. Come on. Okay, better. All right, who wants to share their answer for this one?
Hold
Okay, I'm holding on.
on.
Okay, anybody online up for it? Megan, please do.
Okay, so you do 72 minus 63 is your
Right, so 72 is your data point, yep.
minus 63, that's
Mean. Mm-hmm.
And then you gotta divide it by 12.
Right, and so that z-score, remember, this has to be in parentheses if you do it all once in your calculator, or if you do it in 2 steps, you just do that first, then divide by 12. And what'd you get?
I got 0.7.
That is exactly right. Okay, so what does that mean?
That you're like 0.75 different from your class.
Yeah, it's just how many standard deviations above the mean you are. So you would say, I am 0.75 standard deviations above the mean. Now, later in chapters, we're going to be doing that chart in the back of the book that tells you like exactly what your percentile is compared to your classmates. But that's all we need to know for now. And the homework's on the bottom. Anybody have any questions for me? Congratulations, we've now done 2 out of 3 chapters of review.
Miss Nussbaum, can you write the steps of the calculator thing again? Because I didn't write them down.
Sure.
Thanks.
Okay, I'm not gonna do the steps again, but I'll say it slow, okay? All right, so first, you hit stat. And then edit. And then you clear out your list by going to like the top thing and hitting clear and arrowing down. Or I guess you could just delete everyone personally on the list, which sucks. Put the numbers in. And then hit second quit. Stat again. Over to calc. And then you click one variable stats. On the newer calculators, is one variable stats still the first choice?
Yeah.
Okay.
Calculators. I don't know who you're talking to.
And then you just hit enter. If you had a list other than L1, you would have to do this where like you would give it a reference point. So you'd have to actually hit, you see how like if you hit second and then number 1 on your calculator has like a little yellow L1 by it. And you'd have to reference like exactly. So if you wanted it to be like list 2, you'd say like that one and reference where you wanted it to go. But as long as you're still in L1, then you don't even have to write that, and it just tells you all the answers. Is that good, Krista?
Yeah, thanks.
You're welcome. All right, you guys can sign off when you're ready.